Okay, welcome back. Chapter 5 is starting and Section 1 is called Proving Identities. And if this sounds vaguely familiar to you, that's because we did these in Chapter 1 in the Trig book, okay? So on the screen I have just a listing of all of the properties that we use in order to prove identities, and I'm hoping that you can find that sheet that has all of these on here. All right, so let's go ahead and get started. We're going to jump right into some trig identities that we're proving that are a little bit more challenging. So I'm going to go ahead and put the first one up on the screen. And what we want to prove is that the left side of this equation is equivalent to the right side, okay? And so if you remember, I'm just going to over here go over some of the rules. Rule number 1 is really important, and that is you can only work on one side. And that's required, never two sides, only one side. Some other hints are if you have fractions, you'll want to add fractions. So finding common denominators, very common in this section. And sometimes we're asked to factor, and that's just what we're going to do in the problem that I've written on the board. And then sometimes you're asked to change, oh, that's a symbol for change, change trig functions to sine and cosine. All right, and so those are the techniques that we are familiar with. So let me just, I realize I've made a mistake, so let me go back and change this because it is not factorable the way that it's written. So now let's go back and prove this identity. So I should add one more thing, and that is to work on the more complicated side. And so hopefully you're seeing that in this one the left side is more complicated. It won't always be the more complicated side. So on the left side it's already in terms of cosine and sine. There aren't fractions to add together. So what I'm going to do is factor the top. And so I recognize that this is of the form difference of two squares. So I'm going to factor this to cosine squared x plus sine squared x, and then times cosine squared x minus sine squared x. So really we remember in 8th grade factoring x squared minus 9 to x plus 3, x minus 3, right? Outside and inside cancel out, called difference of two squares. We can do that also with trig functions. All right, we're going to leave the bottom the same, right? We remember the Pythagorean identity that turns that to 1. Okay, and so now this simply becomes cosine squared x minus sine squared x over cosine squared x. And sometimes we get confused and we think that the numerator should be replaced with something, and it really isn't. This is not a formula that we use at this point. Later on we'll learn more about that, but for right now we can't do anything. So then last thing I'm going to do is split it up into two fractions, and so the first one is cosine squared x over cosine squared x minus sine squared x over cosine squared x, and that turns out to be 1 minus tangent squared x. And if you look back at the top, that's what we were going for. All right, so hopefully you're feeling like you're back in the swing of it. There's one new thing that I have to teach you, and that is sometimes you have an identity to prove where none of the techniques will help you that you know so far. So we need a new technique, okay? So we think about, got to work on one side, and they both look kind of equally complicated, and changing to cosine or sine or factoring or finding a common denominator, none of that works here. And so this new technique has to do with conjugates, and we've had conjugates when we've talked about square roots in the denominator. Remember, we'd have 2 over 3 plus the square root of 6, and we'd multiply by 3 minus the square root of 6, 3 minus the square root of 6, right? And what would happen is it would get that square root out of the denominator. So we're going to do something similar to this. But what we're going to do is we're going to pick, and it doesn't matter which side, it'll work out whether you do either one. And so I'm going to work on the right side this time, and I'm going to multiply by the conjugate of 1 minus sine x, and that would be 1 plus sine x. Okay. the purpose of it is not to get anything out of the denominator. What happens is that it allows us to cancel that cosine and get to our answer. All right, so in the top I am not going to distribute. I'm just going to write that. And then in the bottom, when I FOIL the bottom, I get 1 minus sine squared x. Right? I did that really quickly. You could take some more time to show that that's what you get. Well, we know that because cosine squared x plus sine squared x equals 1, we can move that sine squared over and say that means that cosine squared x is 1 minus sine squared x. Remember that from chapter 1. So what I have in the top is still cosine x, 1 plus sine x. And then in the bottom I have cosine squared x. So now I can do a little canceling, right? And so what I'm left with is 1 plus sine x over cosine x. And if you look back up, that's exactly what we wanted to happen. So how do you know to use a conjugate? You just have to do a lot of problems, and usually this shows up when you've tried everything else and it doesn't work. Okay, we have another day to practice these in class. You're going to get really, really good at them. See you in class.